Okay, so now we are ready to get into our right triangle trig. Now, up here in the top left, it probably looks like some weird word. It's actually an acronym to help us remember some certain things. We'll get to that in a second. Here's a couple notes. We know that there are 3 different sides to a right triangle. There are 2, and then that meet at a right angle. These are the legs, which is what we kind of talked about earlier. The 2 legs make up the right triangle, and there is 1 hypotenuse. Which is always the longest and opposite the right angle. Opposite the right angle. When we use trig, we have to distinguish between the 2 legs. We'll always have 1 angle along with a right angle whenever we use trig. This is called a reference angle. Reference angle. To label the legs of the triangle, we circle, that should just be circle, the reference angle, and draw an arrow across to the opposite leg, and the other one is called the adjacent, because it is touching the reference angle. Okay, so now, big thing here is notice down here at all these triangles, none of them, well, in the future here, none of them are going to be 30, 60, 90s. Okay, so we're not going to see the angles. We're just going to, if you don't see a 30, 60, 90 or 45, that tells you we're going to use SOHCAHTOA. Okay, for these, we're just going to use our reference angle. So here, angle X, I'm going to introduce a new variable here. It's a Greek letter, and it's called theta. So for X, I could do a little theta here, which is kind of like a cursive O. All right. So whatever that angle is, it's treated like another variable. For some reason, they use this theta to symbolize an angle. And it's a variable just like X, Y, Z, any of those types of things. Okay, so all we're going to do is we're going to label opposite, adjacent, hypotenuse. So here's my 90 degrees, which means I'm going to have the 2 legs here. But anytime when I circle this or I circle my angle that I'm using, I'm going to point an arrow opposite. So this is O for opposite. Okay, the hypotenuse from before is always opposite the 90, so that I can locate the 90, look opposite. So this is the hype, which means this is the adjacent. So you can just use H, O, and A if you want. For letter B here, I'm going to locate, angle C, that's here. Angle C, I'm going to put that little theta thing there. And then I can circle angle C, arrow opposite. Opposite the 90 is the hypotenuse, and whatever's left over is the adjacent. Okay, go ahead and try this one on your own. You can pause, I'll give you a little bit of time. Angle Z, I'm going to put a theta here. Okay, point, opposite, adjacent, hypotenuse. And the last one, opposite, adjacent, hypotenuse. Opposite and adjacent are always connected by the 90. Hypotenuse is opposite the 90, further away. All right, so that's half the battle. Okay, so now, whenever we're doing this, the sine, cosine, and tangent functions are different ratios built into your calculator and can be used to solve for missing angles in a right triangle. Okay, below are a couple examples of equations we will solve. Whenever we use these functions, we need to make sure our calculator is in degree mode, degree. Now, if you have a graphing calculator like this, Let's see if I can make this a little bit bigger here. Nope. Okay, whenever you're doing this, to check the mode, you just hit mode in your calculator, and then this should be highlighted. Okay, so like if you were to reset your memory, so 7, I might have you do this in class a couple times. Reset to, okay, everything's cleared. That's just to make sure everything's cleared out of your calculator. Now, whenever you hit mode from that, it defaults to degree, or it defaults to radian. So we have to make sure we go to degree mode. Whenever I tell you that, this is what I mean. There we go. Okay, you just hit second quit, and then we should be good. All right. So whenever we solve these, it's just like cross multiplying. Sine 37 is one number. Okay, it's a ratio. It's the sine ratio for 37 degrees. So whenever we put that in our calculator, sine 37, boom. We treat that as one number. Okay, so it would, even though there's a bunch of letters in there, you know, it just looks a little bit different. So whenever we have this, treat this kind of like if I had 37 over 1 equals 25 over h. We can cross multiply this fairly easily. Okay, we've done that a lot. So I can do the same thing here. Only now I just bring this sine word with it. So this would be 1 times 25, which would be 25. Okay, equals sine 37 times h. Okay, so now through multiplication, to get rid of multiplication, I would have to divide on both sides. So since this is one number, this would be like 37h. So I would have to divide both sides by sine 37 divided by sine 37. So these guys would cancel out. Then I'd have h equals, now in your calculator, you can use this like as the fraction. Some of you guys can write them vertically like this, others you may not. 25 divided by sine 37. And I'll show you how to do that right here. So I'm dividing here. So I'm doing 25 divided by sine 37. Close your parenthesis, and nearest tenth is what I want to, so it'd be 41.5. Okay, 5/4, it's going to just be a 5. So 41.5. 41.5. Boom. Next one. All right, same thing happens. Boom. I can cross multiply. 1 times a is just a. Cosine 29 times 50 is just cosine 29 times 50. Now, notice how I close that parenthesis. Okay? Close that parenthesis. That's going to be different than if I kept that open. All right? Another way to write it is a equals 50 cosine 29. Just make sure that these two right here always travel together. Always, always, always. So I could do 50 cosine 29. 50 cosine 29. I could do it that way. Or I could do cosine 29. You can do the multiplication sign of 50. Okay, you get same answer. Now if I did this, cosine 29 times 50, and I forget to close that parenthesis, yeah, that's a little bit different. Okay, but this is one of the classic examples of, like, your answer looks completely off, but all you did was you forgot a parenthesis. Like, you did all the work correct. Okay, so don't get too frustrated. Your answer here is 43.7. 43.7. Now here, okay, I can't just divide by a tangent. Okay, I can't just take the tangent of something. So this, anytime here, this is my angle. Anytime you solve for an angle, you have to use what's called the inverse. Inverse. Okay? To do that, you'd have to take second tangent, or tangent -1 of 22 over 33. Okay, so whatever this is, you're not cross multiplying here. Okay, whenever you solve for an angle, you have to take the inverse of whatever that is. So whenever you go back to your graphing calculator, so like right above each sine, cosine, tangent, you should see the blue ones. So I'm going to go second tangent, the second button, tangent of 22 over 33. So that'd be 33.7 degrees. So this, theta, or my angle, would be 33.7 degrees from there. Okay, I'm going to have you guys go ahead and try these. I will probably pause it for you. But yeah, I'm going to have you go ahead and try these on your own. This can be done the exact same way. So I'll just draw it out here for you. All right, there we go. Okay. For any right triangle with referencing angles, the three ratios are defined as sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, to figure this out, some of you guys are going to be like, man, how in the world am I going to remember this? Well, at the top, at the beginning of our section here, we had written out SOHCAHTOA. So that's going to tell us that our sine function is opposite over hypotenuse. Our cosine is adjacent over hypotenuse. And our tangent is opposite over adjacent, SOHCAHTOA. So it tells us each one of those. So if we go look back over here, whatever our reference angle is, we have opposite, adjacent, and hypotenuse.